My name is Kashal Alvin Sali. I'm a private student offering computer science. My student number is 2300709144. My registration ID is 23/U/09144/PS. This is my presentation regarding the assignment that was allocated to us computer students to the questions of number one, explaining the history of computers in terms of generations, and number two was regarding the evolution of the Intel x86 and the ARM architectures. Starting off with number one, the first generation of computers lied between the years of 1940 1956. These computers used vacuum tubes as the main electronic component and the magnetic drums and tapes as the main memory. They are very large in size, expensive, power hungry, and prone to overheating. These computers used machine language, which was the lowest level programming language and could only solve one problem at a time. They used punched cards and paper tape as input and output devices. Their typical speed was estimated to be 40,000 operations per second. Taking examples of the first generation computers, we have the ENIAC and the UNIVAC. Then after that, of course, we went to the second generation of computers. These laid between the years of 1956 to 1963. The major introduction to this generation were the transistors, which were used as the main electronic component, and of course the magnetic cores as the main memory. These computers were smaller, cheaper, faster, and more reliable than the first generation computers, and they used assembly language, a slightly higher level programming language, and could perform multiple tasks at a time. Magnetic tape and discs were used as the input and output devices. Talking about their typical speed, the typical speed was estimated to be 200,000 operations per second. Examples of these second generation computers, we have the IBM 1401 and then the IBM 1620. Then after that went to the third generation of computers. The third generation of computers lied between the years of 1964 to 1971. They used integrated circuits as the main electronic component and semiconductor memory as their main memory. They were even smaller, cheaper, faster, and more reliable than the second generation computers. They used high-level programming languages such as Fortran, COBOL, BASIC, and Algol, and these computers could perform complex operations at a time. They used keyboards, monitors, printers, and magnetic tape and discs as input and output devices. Their typical speed was estimated to be 1 million operations per second. Giving examples of the third generation computers, we had the PDP-8 and the PDP-11, and of course the IBM 360. Then up to that, we went to the fourth generation of computers that started off in 1971 up to the present. There was a major introduction of microprocessors as a main electronic component. The main memory was categorized in terms of RAM and ROM. These computers were even smaller, cheaper, faster, and more reliable than the other generations of computers. High-level programming languages were introduced and used by these computers such as C, C++, Java, and Python. These computers, having a high processor speed, could perform multiple tasks simultaneously. The input and output devices were keyboards, mice, touch screens, monitors, and printers, and so on. The estimated speed was 10 million operations per second. Examples of fourth generation computers, we have the IBM PC and the Amiga and the Atari ST. Then after that, we went for the fifth generation of computers that kicked off in 1991 and beyond. This is also known as the future generation of computers because it's still under development. It emphasizes the use of AI, also known as the artificial intelligence, as its main memory. These computers aim to be smaller, cheaper, faster, and more intelligent than the fourth generation computers. They use various high-level programming languages that support all features. These all features are Prolog, Python, and so on. And these enable them to perform human-like tasks such as learning, reasoning, decision-making, natural language processing, speech recognition, and then computer vision. The various input and output devices enable these computers to carry out human-computer interactions such as voice commands, gestures, facial expressions, and so on. The typical speed is estimated to be over 100 million operations per second. And then giving examples of these fifth generation computers, we have the Google Assistant, Siri, and Alexa. Then after that, I move to number two. Number two requires us to give the brief evolution history about the Intel x86 and the ARM architecture. I'll begin off with the Intel x86. The evolution of the Intel x86 is a process of how the Intel x86 architecture has changed over the years from its first generation in 1878 to its latest generation in 2022. The Intel x86 architecture is based on the Intel 8086 CPU and its variants, and it has been used in various types of computing systems such as personal computers, of course workstations, servers, smartphones, tablets, and then also supercomputers. These are some of the main features and milestones of the Intel x86. Number one, the 8080, the world's first general purpose microprocessor. This one had an 8-bit data path to memory. It was used in the first personal computer. Then next on the list we have the 8086. This was the first 16-bit machine which had a wider data path of 16 bits and large registers. It was introduced to the concept of memory, segmentation, and prefetching. It was used in the IBM PC and of course its clones. Then next, we have the 8086. This was the first processor with 16-bit addressable memory of 16 MBs. It used two models, the real mode and protected mode. It had a data transfer with 16 bits and programming mode of 16 bits. And then next on the list we had the 8386. This was also a first processor with a 32-bit architecture, which allowed it to compete with more powerful machines. It supported multitasking and paging, and of course it had an addressable physical memory of 4 GB and a data transfer with 32 GBs, rather 32 bits. Then after that we went for the 8486 processor. It was the first processor to introduce cache technology and instruction pipelining. It had a write protect feature and a built-in math core processor, which also implemented the concept of paging. Then after that went for the Pentium. It was the first processor to use Pascal techniques. These allowed multiple instructions to be executed in parallel. It also added features such as page size extension, register, rimming, branch prediction, to mention but a few. Then we went for the Pentium Pro. This was the first processor to use register renaming. This helped it to improve performance by allowing fast access to registers. It also used branch prediction, which reduced branch mispredictions by analyzing the code ahead of time. It added advanced optimization techniques in microcode along with level 2 cache. And then after that went for the Pentium 2 version. This was the first processor to use MMX technology for multimedia processing. It also added support for SSE instructions for streaming processing. Then after that went for the Pentium 3. This was the first processor to support SMD instructions for streaming multimedia. It also had support for SSE instructions for streaming processing. Then after that, of course, we went for the Pentium 4. The Pentium 4 was the first processor to implement third generation address translation. It translated a 48-bit virtual memory address to a 48-bit physical memory address. Then we went for the current processor, which is known as the Core I. This current generation of Intel processors that use a hybrid instruction set of architecture that combines legacy x86 instructions with new instructions such as AVX512 for vector processing. These processors also use advanced technologies such as hyperthreading, turbo boost, dynamic frequency scaling, power gating, and of course integrated graphics rather. And then after that I go to the evolution of the ARM architecture. The ARM architecture The evolution of the ARM architecture is the process of how the ARM architecture has changed over the years from its first generation in 1985 to its current generation in 2022. The ARM architecture is a family of RISC instruction set architectures, also known as the ISAs, for computer processors. These were developed by ARM Limited Company and licensed to other companies who built the physical devices that used this instruction set, giving the different variants starting off the one in 1985, the current one in 2022. I begin off with the first ARM1. This was the first processor based on the ARM instruction set with 32-bit internal structure, but it had a 26-bit address space that limited it to 64 MBs of main memory. This was designed by Acorn Computers and was used in its Acorn Archimedes computer 12. Then after that, I moved to the ARM7. This was the first processor to introduce thumb 2 instructions, which are 16-bit instructions that can be used for lower power applications. It also introduced DSP instructions for signal processing. It was designed by Acorn Computers and of course using the Acorn RISC Machine computer. Then after that, I go for the ARM9. This was the first processor to support SIMD instructions, which are instructions that perform vector operations on multimedia data elements. It also introduced advanced encryption standard known as the AES instructions for encryption, and still it was designed by the same company, ARM Limited Company, and still used in the PowerPC processors. Then after that went for the ARM11. This was the first processor to support Neon in full non-executable order reduction instructions, which are instructions that perform floating point operations on multiple data elements. It also introduced DSP instructions for signal processing. Of course, it was designed by the same known company, ARM Limited, and this was also used in PowerPC processors. Then after that, I go for the ARM version 6. This was the first processor to support thumb 2 instructions, which are 16-bit instructions that can be used for low power applications. It also introduced DSP instructions for signal processing. It was designed by ARM Limited and of course still used in the PowerPC processors. Then after that, I'll go for the ARM version 7. It was the first processor to support SV instructions, which are instructions that perform vector operations on multiple data elements. It also introduced DSP instructions for signal processing. It was designed by the same company, ARM Limited, and used in PowerPC processors. And then after that, I go for the version 8 of ARM, and of course, which is the current version. And this is the current generation of ARM processors that use a hybrid instruction set architecture but combines legacy ARM instructions with new instructions such as VFP version 4D16, a floating point unit with double precision, and then also VFP version 4 with a floating point until unit with single precision. Those are many examples, but to mention a few. This same generation also used advanced technologies such as hyper-threading, dynamic frequency, scaling, propagating, and of course integrated graphics. That was a brief history on the evolution of the Intel x86 and the ARM architectures. I remain Kasha Alvin Sali.